Let's continue our look at inverse functions in section 2.7. One of the things that's important to keep in mind about an inverse is that a function performs a set of operations on its input. The inverse of that function unravels or undoes the set of operations that the function performs. For this reason, we learned something really important about a function and its inverse. And that is, if AB is a point on the graph of F, then the point BA is a point on the graph of F inverse. This fact gives rise to the reflective property that exists between a function and its inverse. The graph of F inverse is a reflection of the graph of F about the line y equal x. So in other words, if I know a point on F whose coordinates are AB, then I also can conclude that the point BA is on the graph of F inverse. And so we want to take a look at this property and what it looks like. So here's an example of the graph of a function. So this red curve is the graph of f of x. Now notice my mirror is the line y equal x. And notice how these two functions are symmetric to each other with respect to the line y equal x. So if I have the graph of one, I can get the graph of the other by using this reflective relationship. So let's use the graph of our function f that's given to sketch the graph of f inverse. Now, one of the things I want to do is I want to look at these points that are detailed. And notice that we have the point 3, 5. So we could make a table. And essentially, we know that whatever point is on F, all I have to do to get the corresponding point on F inverse is interchange the coordinates. So if 3, 5 is on F, 5, 3 is on F inverse. If 1, 4 is on F, so I'm just looking at these highlighted points. So this point is the point 1, 4. Then the point 4, 1 is on F inverse. And if this is the point negative 3, negative 7, then the point negative 7, negative 3 is on F inverse. And for this particular graph, that's actually enough information for us to sketch the graph. So I'll plot the point 5, 3. And notice that's the mirror image of this point. If the line y equal x is our mirror. So notice this dashed line is the line y equal x. And notice how the distance from this point to this line, so the distance from y equal x to 3, 5 is the same as the distance from y equal x to 5, 3. Let me plot the point 4, 1. So that's the mirror image of this point. And then let's plot the point -7, -3. I'm sorry, I'm thinking backwards there. All right, and so -7, -3 is the mirror image of this point. And so then let's connect these with lines. Okay, and so here we have the graph of the inverse function, y equal f inverse of x. And just using symmetry. And so everything has a reflective property when I'm looking at a function and then comparing what I see in the function to its inverse. So one of the interesting things is, now notice here, f is increasing steeply. We have a steep increase in f. Well, corresponding to that is a slow increase in f inverse. Here where we have a slower increase in f, we have a very quick, steep increase in f inverse. Another thing is the y-intercept of f reflects and becomes the x-intercept of f inverse. The x-intercept of f inverse reflects to become the y-intercept, or the x-intercept of f reflects to become the y-intercept of f inverse. So those are some of the relationships. Some other interesting notes are that the vertical asymptote of f reflects to the horizontal asymptote of f inverse, and vice versa. The horizontal inverse of f reflects to be the vertical asymptote of f inverse. So those are some of the interesting aspects of the reflective property of a function and its inverse. This reflective property is what we are going to use to find the inverse of a function. So when I start with a function f of x and I want to find its inverse, I'm going to replace f of x with y in the equation for f of x. Then I'm going to interchange x and y, because I know that an x on f becomes the y coordinate on f inverse, and the y on f becomes the x coordinate of the inverse function. So I interchange x and y, and at this point, that y is now my inverse function. So for that reason, I solve for y. And notice if this equation, when I solve, does not define y as a function of x, the function f does not have an inverse function, and this procedure ends. If this equation does define y as a function of x, the function f has an inverse function. If f has an inverse function, I replace the y in step 3 by or with f inverse of x. And if I wanted to check my result, I could show that f of f inverse of x is x, and f inverse of f of x is x. So let's look at an example of this by looking at number 4, where we want to write an equation for the inverse function, and we want to state the domain and range of both functions. Notice what my procedure says. It says replace y. Instead of calling this f of x, let's call it y. So that's step 1 of my process. Step 2 tells me, and what I want to note here is that in step 1, y is f of x. Step 2 tells me to, wherever I see an x, put y, and wherever I see a y, put x. And once I make that interchange, as I'm doing here, once I do that, now y in step 2 is actually f inverse of x. And that's why I want to solve for that. Step 3 is to actually solve this for y. And I'm going to do that in this case by cross multiplying. Because I have a single rational expression on the left and right of this equation, I could think of this as x over 1 if I wanted to. I can cross multiply, and that means I multiply the top on one side of the equals times the bottom on the other side of the equals. And I set that equal to the bottom on the left side times the top on the right. And this rids the problem of fractions. I can only do this if there's exactly one fractional expression on each side of the equals. So I'm going to distribute. And now, since my goal is to solve for y, everything that doesn't have a y in it is going to be on one side of the equation, and everything that does have a y is going to be on the other side. So I'm going to add 1 to both sides of the equation and also add a 5xy. So that's actually what I've done at this step. I've added 1 and 5xy to both sides of the equals, or the equation. And because I have two terms that have y in it, I'm going to factor that y out. I'm going to use the distributive property here to factor that y out. And then I'm now going to divide both sides of this by 5x plus 3. So 2x plus 1 over 5x plus 3 is y, and remember this y was f inverse. So I now have found f inverse. Now remember, we were asked to find the domain and range of both functions. So I'm going to just kind of go up here to do that now that we have f and f inverse. And I'm going to actually make a table. I'm going to make it a... Okay, so I want to set up a table where I give the domain and range of these two functions. And that's actually going to be very easy to do. Now notice that f is a rational expression, as is f inverse. And the only issues here in this type of function is I have to omit any value that makes the denominator 0. So I have to omit the x that makes 2 minus 5x 0. And I'll have the domain of f. So if I set 2 minus 5x equal to 0 and solve, or not equal to 0, and simplify, I wind up with x can't equal 2/5. So the domain of f is the union of the two intervals -infinity to 2/5 union Okay, so what I'm going to do here is I just needed more space to write. I can't write real small with this electronic pen. So we're going to find the domain and range of f and f inverse. Okay, so we discussed the fact that these two denominators cannot be 0. So 2 minus 5x can't be 0. Which means 2 can't equal 5x if I add a 5x to both sides. Which means 2 over 5 can't equal x. Similarly, 5x plus 3 can't be 0, which means 5x can't equal -3, adding a -3 to both sides, which means minus 3/5 can't be x. So that is how I would actually find out some of the information that I would need. Now, so what we're going to do is we're going to talk about f of x and its domain. And we also want to discuss the domain of f inverse, as well as the range of both functions. Okay, so we see that the only x value I can't put into f is 2/5. So I can go from -infinity to 2/5, and then I have to skip over the 2/5, and I can go put any number to the right of 2/5 into f. So that's the domain of f. Now, one of the things we said early on in our discussion about inverses is that that has to be the range of f inverse. That's the domain of f. Then that's got to be the range of the inverse function. Now when we go to find the domain of the inverse, we see in our work above that we can allow x to be, we may not allow x to be negative 3/5, or the inverse function becomes undefined. So we can use all numbers left of negative 3/5 and all numbers right of negative 3/5 as input to f inverse, and that is our domain of f inverse. Well, that has to therefore then be our range of f. And that's the relationship that we said has to exist between a function and its inverse with respect to the domain and range. And again, remember, this is an interchange of x and y. If the domain is telling me about x values, then the information about x values for f is actually giving me information about y values for f inverse. Here, if I'm getting information about the y values of f, when I look at the range, that's giving me information about the x values of f inverse. So let's continue with this reflective property of a function and its inverse. And here we're given a graph of a function f of x. And we want to use that graph to answer questions about the inverse function, the corresponding inverse. So we want to give the domain of f inverse using interval notation. All right, well, we can see that the range, so in other words, we just need to look at the range of f to get the domain of f inverse. We can see the range of f is from -4 to 5 inclusively. So that's going to be the domain of f inverse. Now we're asked to find the range of f inverse. So we're going to use the graph to look at the domain of f. And I see that the domain of f goes from -5 to 6 inclusively. So that's actually my range of f inverse. So that's the range of f inverse. And so notice what I did. I found the domain of f. That was the range of f, range of f inverse. I found the range of f, and that was the domain of f inverse. We want the x-intercept of f inverse. Well, that will correspond to or reflect the y-intercept of f. So the y-intercept of f is 0, 4. So the x-intercept of f inverse is 4, 0. The y-intercept of f inverse is going to reflect the x-intercept of f. And we see this is -3, 0. So the y-intercept of f inverse is 0, -3. And then we're asked to evaluate f of -4. I mean f of 4. So we see that f of 4, actually what that means is we want to find, if we want to find f, not f of 4, I'm sorry, f inverse of 4, we need to find the y value of 4 on the graph of f, and we see that corresponds to a point whose x-coordinate is 0. So f inverse of 4 then would equal to 0. Because remember, if we're on f and we have 0, 4, then that means on f inverse I have 4, 0. So f inverse of 4 then would be 0. And we could do that, we could do that for more points than just that. And here we're asked about some others. Okay, using the same line of reasoning, f inverse of 0. Well, that basically means we want to find the point on f whose y is 0. So in other words, when we're on f, we have the point -3, 0. Well, that's going to correspond on f inverse. The mirror image of that on f inverse is 0, -3. So f inverse of 0 is -3. Similarly, we have f inverse of -4. Well, all that's telling me is I want to find the x-coordinate of the point on f whose y is -4. And that's the point right here whose y is -4, and the x of that point is -5. So the mirror image of that on f inverse, where the line y equal x is our mirror, is -4, -5. So f inverse of -4 is -5. And finally, we want to find f inverse of 5. So that just basically is telling me on the graph of f, I want to find the point whose y-coordinate is 5. And that's this point. Here's the y, on the y-axis I'm at 5. I have to move to the right to get to the graph of f, and I see the x-coordinate of that point on f whose y is 5 is 6. So the mirror image of this point on f inverse is the point 5, 6. So f inverse of 5 is 6. All right, and so that's those are the key components, including the intro video of inverse functions for section 2.7.